So good afternoon, student. So today let us discuss the last two topic in your syllabus of first unit, that is in circuit emulator and hardware target hardware debugging. We will call it as ICE. In circuit emulator we will call it as ICE, and target hardware debugging we call it as ICD. Okay. So now let us discuss something, then we will see how we are doing this. So let us assume you are doing an embedded project for an automobile or your car. The entire development of this particular embedded system for automobile can be divided into two. One is called software, another team will called hardware. The software team and hardware team, they will not merge. Software team will separately do the programs, and hardware teams, they will be separate. We will not show everything to software team because they are not much knowing about hardware and all. So what we will do, we cannot give a car for them to sit and do and all. So everything is only emulator will take care. So now you must know the difference. So when you deal with software people, we call it as in circuit emulator, and when you come to hardware people, then we call it as target hardware debugging. The thing you have to remember, I cannot give Volkswagen car or Mercedes-Benz car to the both of the team. So only in their test bench they will do and they will test, then they will try to install in your automobile. So till that instant, last instant or last phase of your embedded system, till that nobody will be allowed to go and see what is there inside the car or aware, that is all that such things. So now in circuit emulator is for the software people who try to do all the software related issues and hardware. So now let us assume for a software people, we will say that it is input is on these pins, that's all. Okay, and they will try to give the output on each and every bit on a particular pin. Okay, we will not say how the input is being brought, from what sensor, what type of sensor, and whether it is analog, digital and all. We will know what will be the output, and directly we will give it to the software people. So hardware people only, they will try to get the program, they will try to place the program, and they will try to test. They will try to give the input from the sensor, see whether your program is able to respond and give the corresponding output. Are you clear? There is two part. One is called as software team, another one is called hardware team. So in software team, you will write the program. For the program, I should get the input, so but I cannot give the sensor, so rather I will give an emulator. So if in the emulator, what the emulator will do, you can specify this is the type of sensor, that's all. No actual sensors will not be there, only that what the sensor output will come by the emulator itself. Okay, so emulator will take care of generating the output, and that will be given as an input, and they will try to see. They won't see the actual sensor, that is the part of the first part of the programmer part, and the second part, they don't know what is there inside the program. So first team, they don't know the real actual hardware, and the second team, they don't know the actual real program. Okay, so that is these two. So in circuit emulator, I have told, what is the difference. In a in circuit emulator, I will have some device that is behaving like a sensor. Okay, so that is what this is. So this will try to give like as if it is coming from sensor, and it will go via to your computer. So okay, so computer, in the programmer, we will give all such types of formats that it will go in, and you will try to write the program. Okay, so in circuit emulator, target system remains independent of a particular target system. Here it is independent. So this part you can connect it to any type of, see this entire setup, you can connect it to any type of processor or controller. It is processor or controller independent. Okay, just you for your programmer needs input, that input is given by a in circuit emulator. So the in circuit emulator, when you see, it doesn't actually shows any sensor, but it will give what the sensor will give. So that is called as emulator. So simulation is there, that is entirely different. Simulation is, you don't have hardware, you don't have anything, you will just simulate with the help of circuit. Emulators, you have an hardware, but that is not real hardware. It is just emulating how that particular hardware will behave. Then use your target monitor. So all these three you combine, then you get the final target debugging work is done. So in in-circuit emulator, target systems remain independent. That is what I told. Emulator or ISTE provides greater flexibility and easy for develop various application on single system in place of testing the multiple target system. So whatever type of input you want, you can get it from in-circuit emulator. So all that you don't want to go and purchase that particular type of equipment and then get the output. All such things is not required. So if you say that I am going to get the sense the temperature, no need to go and buy LM35 IC, connect it to a controller, get the pulse and all. This emulator will directly give the output that will be similar to the LM35. So that is what is emulator is. So you will have finally, this is your system where you sit and do your program. So to do this, everything is being generated by the target emulator. This emulator part, it has an inbuilt microcontroller and all that such things. See, I told you don't have physical, so previous itself I know what will be the input. So I will generate with the help of my microcontroller. So that microcontroller is generating as if like what sensor output will be. Okay, this part you don't confuse with the microcontroller on your embedded system. This is not that microcontroller. This is the microcontroller which is there inside the emulator. So emulator manufacturers are there. Okay, so even I will give one more example so that you can understand clear. So you are going to lay a transmission line, say assume from Madras to Ennur. So from Chennai T Nagar, for example I am saying, this is not actually, that is not there. Let us assume, or you have a place in Chennai where you get from grid, power you get from grid. So assume, let us, I am going to put a new transmission line. So now you might have studied something called transients, something like lightning surge, all such things will occur in a transmission line. So based on that you have to calculate and place the insulators, line insulators. Like in tower you might have seen a porcelain circle, black color circle, all that circles are insulators. So now what can I do? Let me go and install and then test. That is not possible. So what we will do, I know if it is transient, what is the voltage level, what is the current level, what is the spike, what is the duration of time, all that I know. So my in-circuit emulator will try to generate the same waveform and try to give it and try to check it. Okay, so that is emulator. So emulator is, it has a wide knowledge, it has wide data. So from with that data will be sent to your computer as if a real-time data is coming. Okay, so for that one reason only I have RAM, read-only memory. So there are separate emulators are available in market. So for automobile you have a separate emulator, transmission line you have separate, then protection device like relay, circuit breaker, for that and all there are emulators available. So that emulator will work for that particular application, but for a wider range, for that application on a wider range. So that is emulator. So emulator will have a data. So all the data will be there in the RAM. Okay, you can see, you can go and search some emulators there. Some emulators will be for transmission line testing and all, will be very costly. Okay, so that will try to generate as if there is some fault in line, as if there is some lightning occurred in that line, but actually speaking there won't be anything. It is only generated by the emulator. Then we will see how your insulators are behaving, how arcing is taking place, all such things. Okay, so that is called an emulator, and finally it will come to your program, and program have to respond and give the answer. The program, what you have to do, you have to open the circuit breaker, you have to open the SF6, you have to open, that is been written as a program, no. So that program will be verified. This is for power sector. If you come for automobile, the emulator will try to give all sort of inputs which can occur when a car is running on a road. So that will be given to your program, and you try to see whether your program is able to control and give output such that it will be useful for controlling the vehicle. So this is called emulator. So an in-circuit emulator will always have an emulating thing and which will be connected to your system. In some case emulator will be also connected to a microcontroller circuit. You can change depending upon the program which is for the testing. So if it is automobile, place that particular IC. In automobile itself, I am going to check for acceleration unit, then corresponding microcontroller, they will place it here. That microcontroller will have all details regarding acceleration unit. And some other, if you want for a braking system, see nowadays nothing is mechanical. That is what I told. Future is only embedded system in automobile, so future is only electronics. Okay, the entire mechanical in automobile is totally removed. See, in olden days you might have seen, you will have a brake pedal. When you press the brake pedal, there will be a rod behind that, and that rod will try to move, and that rod will try to go on it a particular place where oil will be pumped. Now no such thing. Whatever you press on the pedal, on the back of the pedal itself, it will be converted into electrical pulse, and that electrical pulse will go to embedded system, and the embedded system will say what has to be done, and that will directly go and trigger the brake unit in the tire. No such mechanical parts or mechanical thing is there, or we can say we have entirely thrown off the mechanical people from the automobile industry. So now we govern the entire thing. That is what I am repeatedly saying. There is a bright future in embedded system if you try to go in. Only thing, slight thing, you have to get prepared. That's all. Basic C program, how to write with embedded C programs, what is various ICs, what is the current level of microcontroller which is being used. Don't want to understand that but controller and all that they will teach, because each and every embedded company, they will have their own microcontroller and they will not tell it out because that is their thing. And see, nowadays if you see, everything in automobile is totally electronics. You have to sit and think, or if you have to sit and think with the person who knows, then only you can understand. See, imagination is very much required when we go for electronics. You should have more amount of imagination power. Okay, so this is what an in-circuit emulator is. So emulator microcontroller inputs from the sensor. So emulator controlled output for peripheral interface system. Emulate target microcontroller input. All this microcontroller MCU I am saying is not your embedded system MCU. It is the emulator microcontroller which is giving the data required for your program to be tested. Very clear. Emulator is for checking the program only. Okay, emulator is for checking the program. Target hardware device where I don't know what is there inside the program, so I will just test it with a real IC. So that is the difference between the two. So ICE, interface COM port for computer. So you will have an ICU will have a common port which is nothing but serial communication port to the computer. So finally that will come inside your program and you will check. Emulator target, then ICU socket connect to MCU externally. Use computer development object files and X files for MCU. User debugs, and finally you know that when you write a program, whatever you write, finally the program is converted into X. Okay, so that is what we mean to say. Then comes hardware debugging. Now it is ulta. I don't know what is there inside the program. I know only the hardware. So I will try to give an actual input. For actual input, whether the program is working or not. So this is the reverse of that. So during development process, host system is used, then locating and burning the code in the target board. So now that's all. I don't want to see what is the inside the program and all. Now program is not at all required for me. So that is why they say they are locating and burning the code into the target board. That's all. Then they will totally remove the computer part. Now computer part is not at all required because the program is being written in target hardware device. Now we will give the input and try to see whether correct output is coming. See, first part when we say emulator, I had a system, I had a program, I was checking the program. Now checking the program and all is over. So program is completed. Once the program is completed, then that content will be brought in and it will be burned inside the controller. Then remove the computer part itself, the target hardware and software later copied to final embedded system. That is after testing. So once you burn inside the controller and bring it and check it with the target board. So target board is nothing but actual input will be given. So once that for actual input with the software, if it is working, then we will place it in an embedded system inside the car. Finally, see, the entire car is not manufactured on a single day. See, all the sophistication is not brought on a single day. We are continuously working. Okay, so see, even when you sit on a Mercedes Benz, there is a difference between sitting in Mercedes Benz car and an ambassador car. Okay, but both are car. All has four wheels you have steering, you have control, accelerator and all is there, but two cars are not same. So what is the difference? The difference is the sophistication what you do inside, and the sophistication day by day we will try to improve. Okay, see for example, when you take Toyota Crista car, even if you are not putting the seat belt, initially it will give warning, then warning will continue, then warning will try to stop the accelerator unit itself. So only after putting your seat belt you can press the accelerator, otherwise it will run only in 20 km speed. So this is what imagination I told you want. Are you able to understand how embedded people has more work to do? So whereas in normal car, I think a red light will be blinking on dashboard, that's all. When you take Ambassador or any car, it will just say you have not fastened your seat belt, so it will just indicate an indication, it will repeatedly just blinking, that's all. But the thing is, humans will try to avoid, but you are supposed to make the human protect. So even though they are lazy, even though they are not cautious, you should make them cautious and you should protect them. The reason for putting seat belt is, under any fast jerk you will not go away from your seat, it will get tightly hold, so that you will not go and hit on anything and get wound. So that is what your seat belt work is. So you should make the person to put the seat belt. So that is what the difference. Okay, the final system functions exactly as one of the test and debug finally during development process. Once this, when your entire embedded has crossed target debug testing, then it is only production. Thereafter no testing. See, once you tested with this and if it is properly working, then it will be directly implemented. Thereafter if there is any problem, that's all, your product is waste. You have told something and prepared something, and but if it's not working, then it is waste. Okay, so host system, PC or laptop or workstation, this is we all know. So program development toolkit is IDE. So like ICE, I told IDE. So this is also commercially available, but for embedded system in automobile they will not sell this. They will have their own. See, I think you might have gone for service nowadays. They will open the bonnet, they will connect a tab. Just they will connect a tab, and from the tab they will get the information that which wire has been cut by your, or any problem, whether any unit is not working, all that will be displayed in that tab itself. So tab itself will show all the details. So all that is possible because of your toolkit. And this toolkit, they will not give it outside, they will have there for own purpose. Each and every automobile industry they will have. Okay, so what is there, that the create source file that stores an edit file gives an appropriate name by the program, can be previously created files, can also integrate various source files, can have save different version of source files, compiler, cast compiler, assembler and cast assembler, all this is there inside that particular tab. Okay, so your previous record, current record, you will just plug in and you will insert, and you will come to know when you have serviced, what is your last service, what is the oil status, what is the level of oil in engine, what is oil in gearbox, all such things will be automatically got as a source file, and you will compile and do all such of things, and you will try to say whether you have to change or not. Okay, so this is the target hardware system. So where you will have target system keyboard, target system display, you will connect if required. In our case, this is called a dashboard of automobile. So from dashboard you will get, you don't have keyboard for automobile, but for some other embedded system application I will have keyboard and all. Okay, supporting I will get it from the program, but the thing is I will not know what is there inside this program. It is directly been host to the controller which is there for controlling the embedded system. So original embedded system will come into picture only in this case. Sophisticated is for a particular type. When you next unit we will come to know what and all the networking is possible. Like there are various types of networking like SPI, USB, IDO, then I2C protocol, CAN protocol, all these protocols are there. So it is like sophisticated communication between the peers. Like you have a main embedded and there are so many embedded controllers, small controllers. In unit 2 we will call them as a task. So each and every task will have its own controller, and the task will communicate with the main system. It's okay. So target system differ from final system. Target system interface with the computer as well as with the work In target system might be repeated downloading and coding during development phase. Target system can made the later on function on an embedded system, designer later on simple copy into final system. This is what I have told. Finally it will be written in an ROM. Entire program will be written in ROM and it will be placed in the embedded system. So with this the unit number 1 is we have completed. So regarding the textbook for you, main first textbook which is you should have is Raj Kamal, that will be oriented towards your syllabus. Then Laila B. Das, that is a foreign author book. So that is your syllabus book which you have to follow. Do you have any doubts?